Here we have a function generator which creates a time varying voltage and an oscilloscope which helps us measure a time varying voltage. The output of the function generator is hooked into channel 1 of the oscilloscope, which is displayed here as the voltage versus with voltage on the y-axis and time running to the right is shown here as a yellow line. The function generator, we can change, right now it says 23 hertz. We can adjust the frequency this way, turn up the frequency, and the wave gets compressed on the time axis. It oscillates more quickly. There's also a fine adjust knob to get more precise changes in the frequency. We can go back to where we were, square waves and triangle waves, and of course sinusoidal waves. And we can vary the output level. So right now I have it all the way turned down to its lowest output level, 30 hertz over here. So let's try to get 150 hertz. So on the function generator, there's these range buttons. So besides the frequency adjustment knobs only go so far. Let's see, on this 50 scale range, it'll go up to 54, almost 60. So I'm going to put these back in the middle and adjust the range to 500, so an order of magnitude higher frequency. 306, I'll go decrease the course frequency to get close to 150. Oh, that's really close. And I'll use the fine to get, so it says 150 over here. That's about 150. Now let's also turn up the output level a little bit. Let's turn it way up. About a third of the way up. Now, I'm not sure you can make much of this. Let's make the picture on the oscilloscope more clear. So channel 1 is here in yellow. The volts per div knob will adjust how much voltage you can, each one of these tick marks vertically means. So I'll turn it down, and now this number down here changed. When I had it set here, it says 1 volt. That means each horizontal line is 1 more volt. Turned it down here, now each horizontal line is 2 volts. It still looks like a thick band. Let's try to spread it out so we can see the actual sine wave better. Right now the time division is 50 milliseconds. So if we decrease that, turn it the other way. Let's turn it to the right to decrease the time division. Then we're zooming in on the x-axis. So that looks like a nice sine wave. Either one of those will work. Okay. And we can move it also up and down. Sometimes nice to spread out a couple signals. So that's right at 0. And we could also move it left and right. Whoops, that's a time div. Here's position, horizontal position. So that I could, say, make it look like a sine wave or a cosine wave. Oops. Okay, so this says 150 hertz. Let's try to get a more accurate reading of the frequency here. So this is 2 milliseconds per division. Use this pointer. So this would be 1 division, 2 division, 3, 3.2, 3.3, 2 millisecond divisions. So that's about 6.6 milliseconds. So does that correspond to the frequency that we'd expect, around 150 hertz. We can do the same thing for the amplitude. These are 2 volts per division. So if we go up about 2 divisions, 2 2-volt jumps gives you about 4 volts. So if we wanted to make it 2.5 volts, and we would just turn it down, there's 2, well, half of that would be 3, right? So let's actually, if we want to get it right at 2.5, a better way to do that would to have 1 volt jumps. Then we would have 1, 2, and then adjust the output level to get it right halfway between the second and third division. So that's going to be 5 volts peak to peak, or 2.5 volts is the amplitude of this sine wave. Another feature of the oscilloscope we can use to measure the frequency, for example, or we can measure a lot of things, but we can click on cursor, and this gives us these vertical bars. So we can adjust the right one to the right and put it, right on the peak of the sine wave. And then that looks right on the peak. Press select again. Now it's selecting both of them. So I just want to press it one more time. So now this one's dotted, and this is the cursor I'm controlling, the left-hand one. Hopefully you can see this okay. I'll move it over to the peak over here. Okay, that looks like they're both right on the peak, or pretty close. So now the information about where the cursor intersects the graph is shown over here. The position of cursor 1, the position of cursor 2, this delta is going to be the difference in time between the two cursors, and it's at 6.64 milliseconds. So that's a little bit more precise than we could say just by kind of counting tick marks. And that'll give you, if you take the inverse of that, a better measurement of the frequency. I think that's it for part 1. Let me check my lab manual. Oh, you need a square wave. I'm going to just push this button, and you can take a look at that. And that's that. Tune back in for part 2, coming soon.